Hi, this is Kevin Trainer. Welcome to my tutorial for the coding assignment that I've created for Chapter 9 of the Zelle 3rd edition Python book. And your assignment is going to have two parts. And although I'm only going to do a single tutorial here, and that'll be pretty clear in a bit that I'm going to show you one problem, and then I'm going to tell you how to take an approach to it in two parts. Okay, so I'm only going to do one tutorial. I'll have a place where you can pause in the middle if you want to go take the same approach to your assignment problem, and then come back and watch the rest. So I'm thinking that you probably just played the lecture recordings for Chapter 9. And Chapter 9 has really two subjects. Subject 1 is how to do probability oriented work in Python. And the big example in the chapter is how to simulate uh, a, uh, a series of racquetball games. Okay, and I think that Zelle does a great job on this. Um, uh, the other subject, and this is why he does such a great job, I think, is how do you design a program? Okay, how do people go about program design? What's the right way to do it, or what are the ways that one could do it? And he shows us a couple of different ways, and he talks about a few more, and I'm going to show you even one further one. But he basically says that what we're looking here is I'm going to show you a subset of the slides from the chapter. He has this a program that he creates to simulate an unspecified number of games of racquetball. It's user chosen, and he represents that with the symbol n. And so you can see here, one big part of the program is called sim n games. Uh, and what he really has here is a program structure chart. And these have been popular for a very long time, 40 to 50 years. So a long time. And they're good because they show you two things. Okay. One is they show you a division of the problem into parts that we think are uh, about the right size and about the right subject. Right. So, for instance, he thinks we have to print the introduction. Then we have to get the inputs. And the inputs to his game are the probability that player A wins their serve, the probability that player B wins their serve, and N, which is the number of games that you're going to simulate having them play. And then he's got sim and games, which um, uh, he has to pass again what he just got from the inputs, the probability of A, probability of B, and N. Um, and then what does he get back? Well, he gets the number of wins for A and the number of wins for B. And then he has to print the summary. So he has to pass that the number of wins for A and the number of wins for B. And so he's divided this program up into a bunch of functions, which is the way that you do this in Python. And he's showing here that the functions have really specific interfaces. Okay, the main code that coordinates the program, uh, it's responsible for the overall game play, the overall simulation, whatever you want to call it, and uh, it has to keep certain information in the main function in order to do the orchestration among the parts. So to print the intro, there's nothing past a back and forth. But when he gets the inputs, he gets three variables back. Uh, Main's going to have to hang on to them in order to pass them down to sim n gains. When we call sim n gains, we get two variables back. And main's going to have to hang on to them in some local variable inside of main in order to pass them down to print summary. Okay, so what makes this a good design is that well, I want to talk about one more thing before this. Down here, he's got the rest of the design down at, he calls this, and we typically do, the main level, we call this level 1. And then the one with 4 boxes we call level 2. The one with Sim 1 game is level 3. The one that has a function that determines if the game is over is level 4. And he's showing the specific interfaces, what goes in and what comes out of each of the functions. So the interfaces are sharp. Okay, that's one thing that's good. Two is it seems to be pretty well thought out. What we look for, and I think I mentioned this in my lecture, is we look for each of the modules in the program, which in Python are functions, or if it's object-oriented Python, they're methods. We want them to have two properties: high cohesion and low coupling. Okay, what's cohesion? Cohesion is the property of all of the code in one function being about the same thing. Okay, and we saw that when he turned this into code, if you look at the print intro, it's pretty much about the same thing. The get inputs, they're kind of about the same thing. I mean, they're kind of inputs for different uses, but this is a decently cohesive. Sim and games is a pretty cohesive idea. You know the number of games that you want to simulate, and you just want some code that is going to simulate the number that you want simulated. And then you're going to have some results to report back. And print the summary is pretty well thought out. The other cohesive thing here is that it generally makes sense when you're doing a series of things to figure out how to do one of them. Okay, so what he does is down at the lower level, he simulates one game. Okay, and then he figures out, well, what do you need to do to simulate one game? Okay, well, you need this probability that A is going to win their serve, probability that B is going to win their serve. That's all you need. And what do you get back? Well, you get the score of A and the score of B. And from that, you can figure out who won. While he's working on this Sim 1 game, he figures out it's kind of complex to figure out when a particular game is over. But it has to do with the rules of racquetball. It would make for some kind of complex conditions in the while loop that he has. So he decides to hide all the assumptions about the rules for the game being over in its own function. So it's a game over function. Okay, so is a game over cohesive? Yeah, it's a really tight idea. Sim 1 game? Yep. So they're all cohesive. They're all about the same thing. And then the main, it's about a number of things, but it's cohesive in that it's all about the orchestration of the solution of the problems. It's sort of the conductor of the orchestra. So high cohesion, absolutely. Low coupling. What's low coupling? Well, that is each of these functions is to know as little about what goes on inside the others as possible. And how do we make that happen? We usually make that happen by passing in only the information that we need to pass in. Okay, so for instance, if we call print intro from main, okay, print intro can't see any of the variables in main, okay? The only way that it can see code is if we, in fact, pass a parameter. So all these things that we're passing down are parameters, okay? Likewise, main can't find out what the results of print intro are unless we send a return value back, okay? And that makes sense too. It turns out that print intro is a pretty dumb function. It doesn't have to know anything about anything. You can do it all by itself. Whereas get inputs, you don't have to tell it any information, but it's going to give you 3 pieces of information back. Sim and games, you need to send it 3 pieces of information. It gives you 2 pieces of information back. And print summary, likewise, you send it 2 pieces of information, and it's just going to print them, so you're not going to get anything back. So when you really see the tight interfaces between the functions here, you can see that they don't know very much about what's going on inside each other, and they only pass each other just enough information to get the job done. And they only get back just enough information to get their own job done. So in the print intro, for instance, it didn't need any information from main, and main, it didn't actually need any information from it, okay? Because print intro is such a sort of a dumb function. Okay, well, great. So his design here has high all the function that he's defined have high cohesion and low coupling. They know very little about each other, and to the extent that they know about each other, it's only in terms of passing data down to functions and then returning results that are going to go up to the calling code. So this is a pretty sweet design. So these hierarchy charts, or as we one time called them, module charts, they've been around for a long time. Quite a few people use them to design their programs. It's a great way to kind of think about your code. When I was a beginning programmer, used to do them like all the way down to the bottom before I would write a line of code. Okay, I no longer do that, but it was a great way to start. Okay, now, what other kinds of ways does he document the design? Well, he makes use of pseudocode. Okay, so he shows us as pseudocode for main. Let's go down here. So the main pseudocode is on slide, I'm sorry, the slide here. Print an introduction, get inputs, simulate and games using probability A and probability B. Print a report on the wins for player A and player B. So that's the pseudocode version that explains the logic inside of main. Do we absolutely have to use a structure chart, a hierarchy chart, and pseudocode? No, you don't have to, but if you're having a hard time figuring out what's going on in the module, the next place to go is the pseudocode. Okay. Would it be possible to write the pseudocode and not do the hierarchy chart? Yeah, it kind of can. That's possible. You can write the pseudocode in a way that you can tell from the text that you're calling a lower level module or a lower level function. Okay, and I think I've actually shown you some pseudocode that has that kind of quality to it. Okay, so certainly pseudocode is much more detailed, and he gives us a pseudocode for the main function. He also gives us a pseudocode for sim n games. Okay. He also shows the pseudocode for, I believe this, it doesn't actually say it, but I believe this is a pseudocode for simulate one game. Okay, just sort of up here. Okay, and now down towards the bottom, he starts to even show you the code. So the second kind of thing that you can do is you can write pseudocode, but sooner or later you have to write your actual code. Okay. One thing we suggested within the chapter is taking a top-down approach, and in the way that we talked about the program, we do have a top-down approach. Okay. So if we were going to draw this chart, we draw it from the top down. If we were going to write pseudocode for each of the functions, we would probably start at the top and work our way through the hierarchy. Okay. He also told us in the chapter that there are some people who do some other approaches. He talked about the prototyping. He talked about spiral implementation, that kind of stuff. And I'm going to introduce, I think I talked about one other idea, which is Agile software development. In Agile software development, we probably do, in terms of the overall system that we're trying to design, we probably do less documentation on paper of all the details of what the requirements are. We do that as in a very kind of a lightweight way. We do probably a pretty lightweight documentation of what the design is. But what we do is we take all these requirements that we have, and we call them user stories, and we put them on this big long list that we call the backlog, the product backlog. And we work with the client to figure out what group of requirements we're going to pick for these iterative development sessions that we have that most people call sprints. And they're anywhere from about 1 week to 4 weeks long. I usually try to get people working about 2 weeks for a sprint, but starting out at one is not a bad idea either. Okay, and so what you do is you pick a couple things and you work on them. Okay, so that means that you don't really have to implement the system. If you can think of this kind of structure chart that we're seeing here, it would be possible to build a whole network of these. It would be the structure of the entire system. So then the question would be, would you have to start at the top and work your way down? In the same way here, we've got the question for this program. Do we have to start to write the code at the top and work our way down? Or is it possible to pick some high priority part that might be in the middle and implement that first? Okay. And why would we want to do it? One, we might want to figure out that we know how to do it. Okay. It might be the one that is maybe the thorniest piece of work that we have. Okay. And the other is it might create the greatest amount of value for the users. Okay. So the approach that I'm going to be doing here, and what I'm going to have you do in your coding assignment, is to take a game, not this game. We've seen enough of this game. But I'm going to have you take a game that has rounds. Okay, so you can play one round or two or 10 or 100, whatever you want to do. So it's going to be a design that's kind of like the one that we see. Okay, so if you were to draw a structure chart for it, the overall layout of the structure chart would look pretty similar. Likewise, if you were to write some pseudocode for it, the pseudocode would probably be pretty similar. But what I'm going to do is I'm going to try to teach you an agile strategy for where to start. Do you always have to start at the top? Okay. Okay, so let's go look at what the requirements are for the tutorial. Okay. Now I've gone from a pretty complex games that certainly not everybody plays racquetball, okay, or understands the scoring. But most people understand a coin toss. So we've gone from a fairly complex game to the simplest of games. So here are the requirements that I have. Create a simulation game for 2 players based upon coin tossing. The coin tossed will be a fair coin with a 50% probability of turning up heads and a 50% probability of turning up tails. That means we're going to be able to use the random functions of Python to be able to simulate it. Prior to the start of the game, the players will decide who has heads, who has tails. During the gameplay, the players would simply be known as player heads and player tails. Each round of the game will be represented by a toss of the coin. The user will be asked at the start of the game, the simulation of the game actually, how many rounds will make up the game. So we could say 1, we could say 5, we could say 10, we could say 10,000, we could say 100,000. Okay? Now if you think about probability, the law of large numbers says if you have a fair coin and there's a 50% probability that it's going to come up heads and a 50% probability it's going to come up tails, the more rounds that you play, the closer the results are probably going to be between player heads and player tails. Sometimes when you play this game, you'll see that, and other times it won't be quite so obvious. Okay, as the game simulation runs, the result of each toss will be reported, and the number of wins for player heads and player tails will be accumulated. At the end of the game, the accumulated number of wins for each player will be reported, as well as one of the following possible final outcomes of the game. Player heads wins, or player tails wins, or if we're playing an even number of games, it's possible for the players have tied. So here's an example. Here's some sample output of a game. Okay. We run the program. Please enter the number of rounds that you wish to play. We put in 10. And then it starts to simulate the rounds. Round 1, round 2, round 3, 4, 5, all the way to 10. And then it's been tallying up the number of wins for player heads and player tails. And then it reports them. Player heads has won 7 rounds. Player tails has won 3 rounds. Player heads wins. Okay, and if the outcomes had been different, it might have said player tails wins or the players have tied. Okay, so if you kind of follow the approach that Zelle took in the chapter, you might create a structure chart for this program. and some pseudocode, or not. Some people can work right off the structure chart. And you would start at the top and you would work your way down to the bottom. Okay. And what I'm going to say is that we're going to take a more of an agile approach, and we're going to say, is there some part of this? How could we break this down into parts where we could work on some high value part first? The first high value part that I think of is just playing one round. Okay. So what I'm going to do is I'm going to break this up into two exercises. The first exercise is to simulate a single round. Okay. And then the second exercise is to take the code that we had from the single round and incorporate it into a solution that plays the whole game. Okay? So what would that look like? Let's get started. Okay? So here we've got the tutorial project, which I created. And I'm going to create a new Python file. And gonna pause 1 second. I'll be right back. Okay. So I'm going to create a program that I'm going to call simulate one round of the coin toss game. Maybe that's a little wordy, but what are we going to do? So let's say, yeah, we're going to add that. We're going to keep it. Okay. So what would I call that? Well, I just want to show you the top of this. I have an already baked version, so I'm going to be bringing over parts to show you. Okay, so I did the typical things. I put the name of the file up here, which makes it easy to see what things are when you print them out. And the intention, a first step towards the creation of a multi-round coin toss game. Now this is an important point in that I want to build this, okay, but I want to build this with the intention that I'm going to incorporate it into something bigger. So I might be a little more generous with the features, okay, than I would be if it was just going to be a one-round game and that's all we were ever going to do with the code. Does that make sense to you? I hope it does. Okay, so let's see. What do we need? Well, we need our typical main, def main. Okay, and I'm just going to put a pass in there so the compiler doesn't complain. And I'm going to have an invocation to main. And that's it. Okay, so let's see. This is just one round. Okay. But I kind of want to do, I kind of want to say, what if we were just going to play one round, but we had to report the result? Okay. So here's what I'm going to do. I'm going to bring some code over from my already baked version. Okay. And show it to you and then kind of talk you through it. Okay, so here's what I've got. Okay, I'm going to want to create a part, okay, that returns a score for each of the players. Okay, and I'm also going to want the part that I create. I'm going to create a function called play one round. Okay, That's pretty clear. Play one round. I could have said simulate one round, I guess. And I want that method to print the line that says what round it is. Okay? So it's going to have to know what round it is. What did that look like? Well, okay. It has to be able to say round one, heads. Okay? So it has to know it's in round one. Okay? So what I really want to see as the output for this is something that says round one, heads. Okay? If I have a program here that only plays one round, well, it's only going to play one round over and over again. Okay, we'll run it. It'll play round one. We'll get a heads. We'll run it again. We'll get a tails. We run it again. We'll get a heads. Run it again. We'll get a tails. But we'll see how that goes. Okay, so that's what I'm talking about. Okay. Then what I want to pass into play one round is the round number, so it can print out the message like I showed you. But what do I want to get back? Well, I want to get back some way to know who won. Okay, and I've kind of taken a page out of Zelle's book in his design. I passed back a score. Okay, well, in one round, it's going to be 1-0, one way or the other. Either score heads is 1 and score tails is 0, or vice versa, right? Okay, now how can I pass back two values? Well, you just say you want to pass back two values. What actually happens is you're passing back a tuple that has two parts. And here, when we do the multiple assignments, we are unpacking the tuple. And here, I just would like to print player heads has 1, and then I want a pretty sentence. So it's going to say, it's going to take the string of the score heads. That's what we just got back. And rounds. And player tails has 1 string of score tails rounds, period. Okay? Okay, so that should give us something. All right. So let's us create play one round. Okay, and I'm not going to bring over all of my code at the same time because I kind of want to have you see it develop. Okay, so first of all, we need a header for the method. Play one round. Okay, and we've got that. Now, what would I really want to do? Well, you know, the work of playing around is really tossing a coin, right? Okay, so do I want to do the, I want to point out that up here I had an import, okay, from the random module I imported randint, okay? Eventually I'm going to use randint to bring back a 0 or a 1. And 0 is going to be heads and 1 is going to be tails. Okay? So, do I want to put that code into right? Do I want to put that code right in line here? I don't think I want to. Okay? Here's what I think I want to do. Toss in a coin. Okay, and simulating that, it seems to me like we're going to have to do a call and get a random number, and then we're going to have to figure out the score that represents. I'm just going to create a method called toss a coin, okay, and it's going to get back a tuple, okay, including a score for heads and a score for tails. Again, this is kind of trivial because at this point, it's always going to be 0, 1 or 1, 0. But that's going to help us later on. Okay, I want to toss a coin. Okay, and then I would like to be able to interpret this. So the left part of the tuple has the score for heads. The right part of the tuple has the score for tails. Okay. So what could I do here? Well, I could do this next part. So let me bring this over from my already baked version and show you what I've done. Okay. So I look at the left part, which I know it's index 0. Okay. And I know that's for heads. And I'm going to want to print out some text that says that heads has 1. So I'm going to want to load up a variable that of what the winner is it heads or tails? So I just ask if toss result with tuple index 0 equal 1, that means heads has 1. So I want the winner text to say heads. Else I want the winner text to say tails. Is there some third possible outcome? No, there's not. And now I can print that line that we were expecting to see. We're going to say round. It's going to take a string of number of the round, and then a colon, and then we're going to put winner text. Okay. All right, that looks pretty good. Have I done everything that I want to do? I have tossed a coin. I've interpreted the results. I printed the results. Okay. Well, that in terms of playing one game, one round of a game, that's probably it. But in terms of where we want to eventually get, which is we're going to want to integrate this into a multi-round game. Well, then something's got to be accumulating the score. And as you can see up here in main, we are expecting to get a tuple back, which we split by saying score heads comma score tails equals the result. So we need to pass that tuple back. So we're just going to say result. Return, and then we're going to return the toss result tuple. So that's how it's going to be available to the code up above. Now I'm seeing some gray squiggly line. I realize in between functions I need 2 lines. So that went away. And I've got the same problem down here with main. Okay, so I'm doing pretty well so far. Okay. Now, what do I want to do? I'm thinking I want to test this. I've probably gone farther than I should without testing. Like, for instance, I should have maybe created a dummy version of play one round. In fact, let's do that. Okay, let's create a dummy version of playing one round. Let's kind of back up and make up for lost time. Okay, what if we said this? What if we print print what round 1 space heads. Okay, and then what if we returned a tuple, 2 values, which is going to be built into a tuple, 1, 0. Heads has 1, tails has 0. Let's see how that plays. Okay, so one of the things that you can do when you're doing this style of programming is you can kind of do a top-down implementation of the part that you've chosen. Okay, and at any point you ought to be able to create a dummy version, a stubbed out version of the code below. So that's what we're going to do here. Let's try to run this. Run this guy. Round 1, heads. Player heads has one round. Player tails has 0 rounds. Okay, so what did you prove there? Well, you proved that you could call play 1 round. Okay, and you proved that you could interpret the results that you got back. Okay? All right. So let's get rid of the phony code. Get rid of phony code. And let's toggle the real code on. Okay. But now we've got a problem. This toss a coin. Okay. It's expecting to get back a tuple with the scores for heads and tails. But we don't have an implementation, so let's create a stubbed out implementation. This is a pretty nice way to do things. So toss a coin. Doesn't have any inputs. Okay. And if you're taking this approach, the first thing that you would do is you just create a stub version. In the stub version, we would say return 1, 0. 1 for heads, 0 for tails. Okay? So let's run that. We get the same results. We get the same results every time, though. Right? It's always heads. Why? Well, because we stubbed it out. Could it be the other way? Sure. We could stub it out and say, what about, can we report it the other way around? Can we properly interpret the other answer? Yeah, I think we can. So let's go down and run this. Round 1, tails. Player tails has one rounds. That's pretty good. I like that. Okay. Very good. Okay, now, this whole thing about, let's just take a look at the code here. So I think I got my type a little too big. Yeah, make it a little smaller. There we go. Do we really need, in order to play a single round, do we really need to pass in the round number? Well, no, we wouldn't. We always know it's 1, okay? But we would like this program piece to be usable when we scale up to the whole game. So, dumbing out the round number to 1 is kind of the opposite of stubbing out the coin toss. Okay, it's a way for us to test communication between calling code and play 1 round. Play 1 round eventually is going to have to know the number of the round because it's going to change. Okay. Now toss a coin is the stubbed out version, so we don't want that. Let's get rid of that. Okay, and I'm just going to go down and I'm going to show you my codes for toss a coin. Oh, just had a hard time picking it up off the one that's already created, but here it comes. Here's the code for toss a coin. Okay, so first of all, now we have to get into the random. stuff. Okay, now in the example from the textbook, we were calling the function random, and I think we were getting a floating point number between 0 and 1. Okay. Instead, here we're calling rand int. We're going to get, because of the way that we called it, we said that the lowest version that we want is 0 and the highest is 1. So it does all the work for us to convert it to integers. So we're either going to get a 0 or a 1 back. Okay. And we're going to want to pass back the proper score. And I've done this in a pretty workman-like way. I'm sure there's a much more elegant way to express this code. But what I said is, the score for heads is 0. The score for tails is 0. If the result that we got back from the random integer is equal to 0, then it's a head. So we increment heads by 1. Else we increment tails by 1. And then we return heads, comma, tails, which, again, when you understand how Python returns multiple values, it returns them in a tuple. Okay, so what are we expecting when we call this? Well, we call toss a coin, and we're expecting to get back toss result tuple. Okay, so let's see that. Let's see that work. So let's run it. Okay, let's give us a little more equal space, make it a little bigger. So player heads has won 1 round. Player, it's heads again. Tails is 1 this time. Tails is 1 again. Heads is 1. Tails is 1. Heads is 1. Tails is 1. That seems pretty random. Okay, that's pretty good. So without a whole lot of work, let's clean up the program here. I think we've got one too many blank lines. Yep, we do. But without too much work here, let's look at the program all by itself. Okay. It all fits on one page. So we have a main. Okay. In this case, even though what I'm trying to do is I'm trying to create a method that plays 1 round of coin tossing. I don't have that. I don't set that up as the code for the main. Okay. Why? Well, I kind of want the code in the main to be testing the method that I'm going to move over into my next version. So I really want a method called play 1 round. All right. So I created this directly. Okay. And then I know that whatever is going to be calling it eventually is going to have to tell it the round it's playing. And it's going to have to report the accumulated score. So I put that into the main. It's a little bit redundant because we are only playing 1 round, but we do want to kind of test that. Okay. And there we are. So again, when we go to run this, we're getting, let's make this big, but we're getting, what we want, round 1 heads, and then we report the cumulative values. So there's the heads. Let's get a tails up here. That's quite a run there. Okay, now we've got some tails. Okay, so that's good. Good, right? Now, what I really like about this from Agile software development point of view is that I could have had this just be the goal for the sprint that we're doing. I could actually go and show users. I could say, look, I've built the part that is one coin flip, okay? And here's how it works. And we run it again and again. You see it works kind of randomly. That's what you're looking for, right? Okay. And we're able to figure out how many rounds we've won in accumulation. But of course, since we're only running one round at a time, it's always for the players either 1 or 0. Okay, so uh, does this look like it works? Yeah, it looks like it works. Looks random enough for me. Okay. All right, so that's what you're going to do in exercise 1. Your game is going to be a little bit more complex than this. Okay, so the example from the chapter I think was overly complex, racquetball. Okay, uh, this tossing a coin is maybe as simple as you can get and still use the probability tools of the random module. Okay, and the one that you're going to be doing is going to use a die. Okay, so you're not going to toss a coin. You're going to roll a die. You're not going to use a randint 0, 1. You're going to use a randint 1, comma 6. Because when you roll a die, you get 6. You get something between 1 and 6. Here we wanted something between 0 and 1. Okay, so this is the breaking point where if you want to take a stop, okay, and go over and do your exercise 1, this is a place, to stop, and then we'll go on from there. Okay. Now, what I'm going to do is I'm going to go and I'm going to take this and I'm going to turn this into a multi-round game. Okay. So, how am I going to do that? Well, first of all, I'm going to have to bring this down and get it looking good. So, what do I want to call this? Okay. I want to call this, I want a new Python file. And I want to call this simulate coin toss game. It's a good name for it, right? So I've got that, and I'm gonna go find my code in my already baked version. Okay. And what's interesting is I haven't changed the comments in my practice version. So we're just going to say simulate coin toss game. I don't have anything to copy that's actually correct. .py, and I'm going to say the full version of the multi-round coin toss game. Okay, and I want to turn those guys into comments, so I'm going to toggle them on. Okay, and let's make that type a little bigger. I'm going to still be using the randint. Okay. Eventually, I'm going to be bringing over the code from the other program. Okay. Now, I want to point out, it's not like we're calling the code. We're not turning that other program into some kind of a module, and then we're going to call a function in that module. That was just a step along the way. Okay. So here's what I'm going to do. I'm just going to go and I'm going to take the code that I have for this guy, and I'm going to copy it. But what am I going to copy? Well, I'm not going to copy this kind of like scaffolding kind of code that tests a play one round. I'm just going to take my play one round code. Okay. And I'm going to copy that. Okay, let's do that. Go right here. All right, so play one round. Now, I need a main somewhere. Okay. It looks like that. And let's just put a pass in there for now. So that's kind of happy. We're getting a complaint that we've got multiple blank lines. But we got a decent amount of code to put in here, so I don't want to screw it up too much. Okay. So, what are we going to have to do in this? What do you have to do in a multi-round game that you didn't have to do in a single round game? Well, the chief thing is you got to take. You have to keep track of the score. That's the first thing that you need to do. So I'm going to define a couple of variables here that are going to hold the score. Okay. And I'm going to put my main code into main. That's where my overall orchestrating code is going to go. So I decided I'm going to have two variables, head cumulative score 0, tails cumulative score 0. That's how we start. What else do we need to know? Well, we need to know how many rounds we're going to play. Okay. Right, that sounds good. So let's go get that. So I'm going to say desired rounds equals int of input. Please enter the number of rounds that you wish to play. Okay. And now you may say to me, you know that structure chart that we got from the Zelle book, that broke that off into its own function. And I'm going to say this: let's just put the solution into main, okay, straight through into main, and then we're going to refactor it. That's going to be the last thing that we're going to do it, okay. Refactoring is a kind of design where you change the design of the code, but not the functionality. And typically, a key thing that you do is that you extract a code from a method and you put it into a separate method. Or if you got too many methods, you pull it up and you include it in the method that called it. So for right now, I think this is okay. We'll do one last refactoring step, and we'll see if that's the way to go. Okay. So we've got the desired rounds. Okay. Okay. Now, let's look at the output that we have. Okay. We have something that tells us, so we do a prompt, we get the desired rounds, then we got a blank line. Okay, and then we go around heads, tails, all of that. We have another blank line after that, and then we have the results. Okay, so we need a blank round before we get into some kind of a loop. We need a blank line before we get into some kind of loop. So let's go take care of that. Okay, we can do that, which is a print with no arguments. Okay, it's going to go there. Okay, that's good. Now, we're going to need us some kind of loop. Okay, I'd say we need a for loop. This is going to be a definite loop because we know how many rounds we want to play. Okay, so let's just start coding that. Let's say for round number in range. Okay, do we want to say range just the name of the variable that we got in? desired rounds. Well, we could, okay? We could do this. We could just put desired rounds in there, okay? The problem is the way range works, because we start counting at 0, range is going to give you a series of values from 0 to desired rounds minus 1. Gosh, that's not what we want. We don't want to have a round 0. So we can do this. We can say range of 1, comma, desired rounds plus 1. That will get us, if we say 10, it will get us from 1 to 10 instead of from 0 to 9. That's good. Okay. Okay, so how are we going to do this? Well, let's call play one round. Okay, and pass in the round number. Okay, let's just take a look at this. So, play one round, round number. Okay, does that do what we want? Well, it kind of does. Problem is, it's going to print out the result, but we're not going to get the score back. Okay? If you call a method, in this case a function, because this is not object-oriented, if you call a function that returns a tuple and you don't catch it, where does it go? Well, it just gets thrown away. So what we really want to say is, oh, let's unpack that tuple that we're getting back into sorry. let's do it like this. If I could type, that'd be dangerous. There we go. So we're calling play one round and passing in the round number. And then we're getting back that tuple that has the score for heads and the score for tails. But we're using a multiple assignment here, and implicitly it unpacks the tuple. So we don't have to show that unpacking explicitly. It happens implicitly. That's the nice thing about being able to pass back multiple values in tuple. Okay, so what's the next thing that we need to do? We have the score, right? We have a cumulative score up here in the top of the main. It's 0 now. We need to bump up either one score or the other on the basis of what we got back in score heads or score tails. Okay, so again, I'm going to show you some code that's not particularly elegant. Okay, but it gets the job done, and it does just fine. I'm just going to put this here. I'm going to say if score heads is equal 1, I'm going to bump up heads cumulative score by 1, else I'm going to bump up tails cumulative score by 1. It's that easy. Okay. Now what else could we do? Well, we need to print the results, don't we? Okay. So how could we print the results? Well, I want to remind you, we need a blank line, right? So we do our 10 rounds. We're pretty sure that we're going to get what we want here. In fact, we don't have to print the results here. This is a good point to test. Can we get 1, 2, 3, 2, 4, 10? Can we get that? Let's do a test there. This would be a nice place to test. So we're right here. We want to run this. Oh, I'm sorry. I'm so confused. I put this. I put it in the right place, but I'm I've got so many so many copies of PyCharm up in so many screens that I forget what we're looking at together. Okay, so this should do it. I just have to run it. So let's run it. And let's look here. How many rounds do I wish to play? Let's make this a little bigger. Say 10. And there we go. Round 1, heads. Round 2, heads. 3, heads. Tails, tails, heads, 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 heads. Boy, a lot of heads. Let's run it again. 10. A lot of tails this time. Okay, run it again. 10. Okay, so I think it's looking pretty good, except we're not reporting the final score. We may be accumulating it, but what we want to do is we want to skip a line and we want to report the final score and also who's going to win. We don't want to announce the winner. Okay, so let's get that done. Okay, so let's do that. I'm going to take this code out of my already baked version. Okay, and I'm going to put it into my main. Get some extra room in main. Okay, so do I want it looking like it's part of the for loop? No, I want it to go right after. So what do? Well, I'm going to print a blank line. Remember that. And we're going to say player heads has 1, and we get a string of heads, cumulative score, space tosses. We want this all to be very pretty. We probably could have gotten away without the string. But I'm not going to worry about that now. And then we say if the heads cumulative score is equal to the tails cumulative score, we want to print the players have tied. If the heads is greater than the tails, we want to print player heads wins. Else, print player tails wins. So let's give that a run. Okay, so got that. Let's make this a little bit bigger. Let's give it a run. Make the type a little bigger. Say we want to run 10. And there we go. So we want to run 10 rounds. These are the rounds. Player heads is 1-6. Player tails is 1-4. Player heads wins. Okay. Let's play another 10 rounder. Player tails wins. Oh, isn't that nice? Let's do it till we can get a tie. Well, you can get a tie that time. I'm not going to make the type big until I tie. Okay. Couple more times. I'm going to pause until I can show you a tie. I'll be back with a tie. Well, you'd be happy to know it only took me 3 more tries. And now we can say player heads has won 5 tosses. I think this is supposed to say rounds. Yeah, I think it is. So I'll change that in a minute. And player tails has won 5 rounds, and the players have tied. And let's just go up here. My original version of this said tosses. I like rounds because we've got rounds on the next game, the one that you're doing, and I think that works well. So 10. Yeah. Rounds. How many rounds do you wish to play? Okay. Well, that's done. Are we done programming yet? Well, this is a part of a design well, first of all, we need to clean this up such that we've got the right number of blank lines in between this. But the last thing that you're going to want to do with just pretty much any piece of code that you're going to be working with is you're going to ask yourself, does it need to be refactored? Refactored. What do we mean by refactored? Well, in refactoring, we're going to change the code but not change the functionality to make it more readable, more maintainable. Okay. Now, most of this code is pretty readable and pretty maintainable. I look at things like function names. Okay. How are function names? Well, the main, it does the orchestration. That's okay. Play one round. That's a great function name. Toss a coin. That's a great function name. Okay, that's good. The next thing I want to look at is do they have high cohesion and low coupling? Okay. Well, play one round, that's only doing one thing. Toss a coin, that's only doing one thing. So, and then the main, okay, it's doing the orchestration. I think it's too busy. Okay. The amount of things that it has control over, I think, is about the right size, but it's kind of too big. Okay, so what could I do? All right, now, what about the initialization of the scores? Well, I can't move that down a level because I've got to keep a score available in main. So I can't really move that down. I can't extract that. It won't gain me anything. This getting the input of the rounds that we wish to play. Well, even if I was to factor that out, even if I was to extract a method, I'd just be calling a method. I'm trading one line of code for one line of code. Not a big gain. Okay. A print here. Again, one line of code for one line of code. And then we've got our for loop. Do we want to move our for loop out? No, we don't really, because we'd have to pass it all these variables. It would have to have access to the cumulative score. And the for loop is really what the main is about. So I'm reluctant to move that out. If it was much more complicated, I would move it out. But it's not complicated enough. It's not too big. But what's big? Well, this reporting the results is big. And you remember, if you go back to what Zelle did in his program, he factored that out into a function. So how can we do that? Well, when you're refactoring, you can just highlight a bunch of code and you can right click and say refactor. And what we want to do is extract a method. Now I realize this isn't a method because it's not an object-oriented program, but that's what the option's called. So we go down to extract method, and it says what do we want to call this? And let's just say print game results. Okay. Now, in order to do that, you have to explicitly pass it the cumulative scores. That's fine. Okay. Now, print game results is right down here all by itself. And now the main, I think it's about the right size and it's doing about the right thing. So I think that's all the refactoring I need to do. I'm happy with main. I'm happy with print game results. Notice that in order to extract the method, I have to explicitly pass these cumulative scores. Okay? Heads cumulative score, tails cumulative score. Now, I want to point out one more thing. When you refactor like this, it can look, when you're looking at the variables in the method that gets called, it can look like they can see all the way up into the main and see the variables there. They don't. They're actually seeing the parameters, these formal parameters that got passed in. They just happen to have the same name. I usually change the name of these so that it's clear that we're not seeing into the main. We can't see into the main. So how do I do that? Well, this is another kind of refactoring where we change the name of a variable. So I'm going to highlight head's cumulative score, and I'm going to say I want to refactor, rename, and I'm just going to call it cumulative score heads. Okay, so I'm just going to make it restate it a little backwards, but it still reads well. Okay, refactor, it changed all those, and I'm going to highlight tails cumulative scores, right click, refactor, rename. And again, I'm just going to call it cumulative score tails. And refactor that. Now, when you look in here, there's no appearance that the code in print game results can see into main and see the variables. It can't. The only reason why we have them available to print is that we pass them explicitly. And that gets me to the other thing. We want to have a high cohesion in all the functions and low coupling, which is the function should know very little about the innards of other functions. Well, having to pass these values explicitly is what gets us low coupling. Yeah, they're coupled to some degree because we know that there is a cumulative score coming from whatever calls us. That's fine. But we don't know what it's called, right? And so what happens when you create all these functions with these explicit interfaces, the only thing they know about each other is the name of the function that you're calling, the variables you have to pass as parameters, and if there's a return value, what you're getting back. So for print game results, we don't get anything back. But for play one round, we get a toss result tuple. Toss result tuple? I don't like that much. Well, let's refactor that, and let's call that round result tuple. So refactor, rename, let's call that round result tuple. Sorry. Get back over there. Round result tuple. Enter. I'm going to undo that. Try it again. Right click, refactor, rename. I'm just going to type it out. Round result tuple. Okay, so now that worked well. So do we have toss in here? The only toss we have is within a round we toss a coin. Fine, that's exactly what we want. But everything else is saying round. I like this the way it is. Okay, here's our main. Okay, it's half a page. Okay, what does it do? It does one thing. It does orchestration, print results, reasonable size, good clean interfaces. We're passing in the values that we need. Play one round, reasonable size, easy to read, good variable names, good function name. Um, Good, clean interfaces. We need to know the number of the round, and we need to send back a result tuple. And then toss a coin. We're not getting anything in, but we are going to return the heads value and the tails. Now, one of the things that happens when you return more than one value is that you implicitly are creating a tuple. Could you say, I want to return a tuple of heads and tails and only be returning a single thing? Well, that's what happens under the covers, but that's not what people usually do. So the Pythonic way to do this is the way we originally had it. That's what Pythonistas do. And let's just take one more test. So let's bring this up and let's run this. And let's say we want to do 10 and 7 to 3. That was pretty lopsided. Let's do it again. 10. 5 and 5. They tied. That's pretty close. And one more thing I told you is that as the number of rounds gets larger, the values should the number of wins for each side should get closer to each other. So let's play 100 rounds. Okay, so difference between 44 and 56. So they're different by 12 in a 100. And let's play 1,000 rounds. And in 1,000, they're different by 478 to 522. So it's 22 and 22. They're different by about 44. That's still pretty high. Let's get up. Let's do 100,000 rounds. Let's see what we got. Takes a while to print out. So 499.14 versus 586. They're still pretty close to each other. You would expect them to converge as the number of iterations gets larger if this is truly a random function. Okay. Of course, we could keep going. We could ask for a million. So that's for a million. 1, 0, 0, 0, 0, 0, 0. Now this would take a little while, but not as long as you might think. There we go. And they're reasonably close to each other. 499.9 versus 591. So that's they're within 100 of each other in a million. That's pretty good. It's pretty fair. Especially attractive if you chose heads. So this is kind of the modern way that people do development. Okay, they don't always design the entire thing from the top down. Okay, it depends on how big the thing is that they're trying to build. If they're taking an agile approach, maybe they pull out some piece that has high value, like that play one game, play one round thing, and get that to work with an eye towards having the code usable when you integrate it into the next bigger piece. And that's what we did here. While you're implementing and testing, it's okay to stub out the methods and return phony results in order to test the calling code. So that's a classic top-down implementation and testing thing to do. And the final thing to think of is the last part of design that you're really doing is when you're refactoring. Okay, that's a design activity too. Okay, that's improving the modularization. You might be extracting a method out of a another method. Um, uh, Renaming of the methods and the variables keeps you from having to have lots of comments. And the other things that you might do is if the interfaces of your functions are a little bulky, the things that you're passing in, let's say you're passing in things that you no longer use, or um, something like that. A final cleanup in a refactoring phase is a final design act. Not everybody talks about it that way, but that's what it really is. So your game that you're going to do, you're going to do in two parts: exercise one and exercise two. Exercise one is going to be a single round. Exercise two is going to be um, uh, more rounds, multiple rounds, right? And it's also going to be different in terms of instead of tossing a coin in which you have two possible outcomes, you'll be rolling a dice, actually, two dice, and in which you'll have six possible outcomes on each die from one to six. So it's going to be different, a little more complex than this, but I think you're up to it. And the overall design that we've kind of borrowed from Zelle Chapter 9, although we haven't really broken out all of the functions the same way. I mean, we're still doing the same thing. We're doing a repetitive simulation game, and that design, both the structure chart and the pseudocode, is a pretty good start. Okay, and you can decide that you want to, go back that far and do that work and put in the details for the exercises that you're doing, or you can decide to just kind of take what we saw in that chapter as inspiration, which is more or less what I did here in the tutorial. But in any case, picking some kind of intermediate point, like playing one round and getting that to work before you try to make everything work, is a really good strategy. And it's really consistent with the approaches that we take these days in Agile software development. So I'd like to encourage you to do it. So with that, I'm going to say bye for now, and I'll see you next time. Bye bye.